Okay, stats 3.4 is z-scores, percentiles, and outliers. Z-score represents the distance from the mean. So if you remember in 3.1 or 2, we drew the bell curve. We talked about how many standard deviations away from the mean it is. The z-score is kind of a normalization of that. It ranks you based on the number of standard deviations away that you are. So how you do this is you take your score, subtract the average, and divide by the standard deviation. And it's either the population mean or the sample mean. Population standard deviation, sample standard deviation, but strategically it's the same. So this is the mean height of males 20 years old or older is 69.1 inches with a standard deviation of 2.8 inches. The mean height of females 20 years or older is 63.7 inches with a standard deviation of 2.7. Data is based on the information from the National Health and Examination Survey. Who is relatively taller? They're asking whose z-score is higher, Kevin Garnett, whose height is 83 inches, or Candace Parker, whose height is 76. So Kevin Garnett is 83 inches tall. The average man is 69.1 inches tall with a standard deviation of 2.8. Candace, this is Kevin Garnett. Candace Parker, z-score is 76 minus 63.7 divided by the standard deviation for women, 2.7. And now we put both of those in the calculator. It appears Kevin Garnett has a z-score 4.96. Candace Parker has a z-score of 4.56. So what does a z-score mean? It means Kevin Garnett's height is 4.96 standard deviations above the mean. Candace Parker's is 4.56. Kevin Garnett's is a bigger outlier because it has a slightly bigger z-score, so Kevin Garnett is relatively taller. Let's do another problem with z-score. A boarding school only admits students who place 1.5 standard deviations above the mean on a standardized test. It has a mean of 200 and a standard deviation of 26. What is the minimum score to get in? So here we're going to go from the z-score back to the original. So we know you need to have a z-score of 1.5, and your score minus the average divided by the standard deviation is equal to that. So now we need to use some algebra to get x by itself. So multiply the 26 over to the other side. And 26 times 1.5 is 39. And then add the 200. So x is 239. It's the minimum score to get in. And another thing that's a comparison is percentile. The kth percentile denotes the set of data values such that k% of the observations are less than or equal to the value. So what that means is if you're in the 99th percentile, for example, that means 99% of people are the same number as you or worse, with 1% being around the same area, 98% being worse. So in the picture, P1 divides the bottom 1% of the observations, P99 divides the top 1%. Jennifer got a 600 on the math portion of her SAT. Her score is in the 74th percentile. What does that mean? Again, what does a percentile mean? It means 74% of SAT math scores are equal to or worse than Jennifer's. That's all it means. And that's all you have to do on those kind of questions when they ask you that. quartiles. So think of the word quarter. A quarter is 25%, so the quartiles are kind of like the percentiles, but they're only specifically for the 25% and the 75%. Now you might ask yourself, why not the 50% as well? But we already have the median, which is the middle number, and the median is already the 50th percentile, so we don't need an extra term for it. So we have the smallest value, the largest value, and then we have the first quartile, the 25% quartile, the median, which is the 50%, and the third quartile, which is the 75%. How do you find the quartiles? It's a lot of finding medians, separating, and finding more medians. So you arrange the data in ascending order, just like the median. You find the median, which is the second quartile. Once you've got the median, you can separate into two groups. The thing about a 25% is it's halfway between 0 and 50%, so you can find the median again. For the upper group, when you find the median again, you'll get the third quartile. So a group of BYU Idaho students collected data on the speed of vehicles traveling through a construction zone on the state highway where the posted speed was 75 or 25 miles per hour. The recorded speed of 14 randomly selected vehicles is given below. Find and interpret the quartiles for speed. Okay. So we need to find our middle number. It's already arranged from least to greatest. There's 14, so that's not going to be an exact middle number. So as a reminder, we have to take the two middle numbers. So from 32 and then average them. Plus 33 divided by 2 is 32.5. This is the median, or Q2. Now, if you average two numbers, they don't go away. If you have one number in the middle, then you get rid of it when you're doing the lower and upper. But when I separate it in half, now I've got this lower group, which is left of my vertical line, and the upper group, which is to the right. Of these 7 numbers, I can find the middle again. The middle is 28, because it's the fourth number. So that means 28 is quartile 1. For the upper side, the middle number of the 7 is 38. That's quartile 3 because it's in the upper half. So what does that mean? 28 being quartile 1 means 25% are going 28 or slower. 32.5, 50% are going 32.5 miles per hour or slower. And lastly, what does the 38 tell us? 75% are going 38 or slower. And if you're going 38 and a 25 in a construction zone where the fines are double in work zones, you are just asking to be pulled over. Now, what is this used for? The interquartile range is the range of the middle 50% of observations in a data set. So just like the mean has the standard deviation to measure how spread data is, the median has the interquartile range to measure how spread something is. So to determine and interpret the interquartile range, so if we recall from the last page, 38 minus 28 is 10. What does that mean? It means the range of the middle 50% of speed of cars traveling through the construction zone is 10 miles per hour. Remember, the range is the largest minus the smallest. Now we will continue this and roll straight into 3.5 in the next video.